So first to speak is Kelly Wanser. Kelly is Executive Director of SilverLining, a nonprofit focused on ensuring the safety in the context of near-term climate risk. They've been the main and most active nonprofit working on what we call solar geoengineering, what she would call solar climate intervention, I guess she'll tell us, and been very active in developing funds for research in that area. Kelly also co-founded and serves as a senior advisor to the University of Washington Marine Cloud Brightening Project. And prior to that, as a technologist and entrepreneur, Ms. Wanser founded companies in IT infrastructure, analytics, and security fields, and has authored about 20 patents.
Thank you very much, David, and august panel. I'm really pleased to be here. I'm an admirer of all of your work, and really pleased to talk to the Energy Seminar Program at Harvard. So I'm going to sort of cover quite a few ideas along the lines that we've been working with U.S. policymakers on. I'm assuming many of you who are attending this seminar have looked into the topic, but I'll give a little bit of a high level that, in particular, SilverLining is focused on near-term climate risk. And that means we're looking at the first order problem of trapped heat energy in the climate system and what that does to natural systems and what kinds of risks it brings to bear in the near term. We look at the near term in the next 30 to 40 years, and we look at solar geoengineering or solar climate intervention in the context of the time horizon in which our portfolio is lacking responses that can significantly reduce that heat energy in the climate system that's causing these escalating risks. And those risks include the extreme catastrophic events that are projected to grow. They include the impacts on vulnerable populations, which the most recent IPCC report places at about 3.3 billion people through the middle of the century. And we're concerned about the problem of what options are available for them, threats to the world species, and the rising risk of major natural systems reaching tipping points in which they rapidly and maybe permanently change state and even accelerate the climate problem. So for us, solar geoengineering, solar climate intervention is really about a portfolio mix, and in particular, looking at the next 10 to 30 years where we lack responses apart from the kinds of things that Steve and EDF work on with respect to short-term forcers in how we really can bring heat energy out of the Earth system quickly. And this is the way we talk about the problem with policymakers. And recently in the United States, in 2021, there were two major reports that are relevant to this problem from the National Academy of Sciences, one looking at the direction of the Global Change Research Program in the United States and emphasizing an orientation toward risk management and management of impacts on vulnerable populations, which was also reiterated in the recent IPCC study. And then a report called Reflecting Sunlight, which recommended a major research effort in the United States on proposals to reduce heat energy in the Earth system by increasing the reflection of sunlight from the planet. So when we talk to policymakers and other people, we start out with this visualization of the sunlight reflecting off aerosols and clouds in the atmosphere. This is a NASA simulation. And as David's talked about many times, the idea behind solar geoengineering, solar climate intervention, is to slightly increase the reflection of sunlight from particles and clouds in the atmosphere. And so that's the sort of fundamental question, is whether those techniques for doing that, which scientists have identified as perhaps the most promising rapid approaches, are viable options for the portfolio and how we might make decisions about them. And I'm going to start out by saying that we've had some success in the policy sphere over the past 3 or 4 years across bipartisan lines, talking about these topics. And one of the things that we think has contributed to this success is the language that we use and the way we talk about the problem. And so in the policy sector, we focused on using language that's more accessible and less technocentric. And we followed the 2015 National Academy of Sciences report in emphasizing the term climate intervention. which also helpfully brings in a sort of metaphor of medicine, which is a similar kind of complex systems problem. We also talk about reflecting sunlight. And so that's helped, I think, ground the conversation quite a bit better in some of these arenas. Similarly, when we talk about the problem space that we're aimed at, we're really focused on fundamental questions of safety, risk, and the generation of information, mostly through physical sciences and physical sciences research, which I'll talk about. And so you will see from me that I encourage members of the community to move away from the geoengineering term, partly because what I'm going to talk about is that the big challenge that we face is a scientific question. And it's the scientific question of aerosol forcing on the atmosphere as the problem that we're aimed at. But in that context, like I said, we've had some success across the aisle, partly because of the way that we talk about it, and partly because the dynamics of the problem are a little bit different than intuition might have told people. And I think Joe Aldi's work on this topic is really interesting, in the sense that in talking across the aisle about topics like solar climate intervention, we've seen a receptivity to an alignment on the severity of the problem with the nature of the solution space that you're open to. And so we've had Republicans tell us that when we're talking to them about these kinds of topics, it enhances our credibility in terms of the level of seriousness that we're talking about with respect to the climate problem, and the orientation that we're taking in terms of the solution space. And so the whole political dynamic has not been necessarily as we anticipated it in terms of what resonates in what parts of the political sphere, but it has been the case that this has been a place for bipartisan cooperation. And there are a couple of reasons for that, I think, and I'm going to talk about a couple of policy principles behind it. But one is that there's a principle in both US and international law on environmental safety. And in the context of environmental safety, in the US thrust, in both domestically and internationally, there's a strong emphasis on the science basis, which means that policy related to environmental safety includes a monitoring component, so a database component, and often includes a scientific assessment, which means that you're able to sort of capture the extant data and information from the scientific community and pull it together and conduct periodic assessments on the state of the natural system. And so I'm going to talk mostly about that, and then I'm going to talk about a couple of concepts that might be newer with respect to climate, and maybe they shouldn't be newer, but disaster risk management and what it means to do risk management and how that links to vulnerable populations and environmental justice. So first, I'm going to just touch on the principle of safety in environmental law and policy. I learned most of what I know from Sue Biniaz and Dan Bodansky, so I encourage you to read their papers on the C2ES website on these topics, which start from the perspective of international environmental law as pertains to this area, and then how that might translate through to a US approach. But this principle of safety is a fundamental context, and it's a useful context for a sort of equitable approach to decision-making. It's one of the better examples of this principle in play is the Montreal Protocol that governs the ozone layer. And interestingly, for the stratospheric form of solar geoengineering, solar climate intervention also governs this area. And we're going to see for the first time a fairly substantial coverage of stratospheric solar climate intervention in the next ozone assessment, which comes out in the fall in 2022. And so you'll see how this starts to play out in terms of the gathering of scientific information, scientific assessment, and how that might feed into the decision process. And with respect to that, I'm going to say we're going to focus on what we've seen in working with US agencies, international scientists, and policymakers as a fundamental question or fundamental problem in solar climate intervention, which is aerosol forcing on the atmosphere. So when we look at research, which is kind of the entry point for policy, we have this problem that clouds and particles influence the atmosphere, which you can see here from a picture of ship tracks in space. That influence from particles, particularly particles generated by human activity, so the particulates and pollution, they're affecting the atmosphere in different ways in different layers, and it's one of the largest uncertainties in climate. And what you can see in this chart, which is an IPCC chart, is we have the anthropogenic effects on climate. The dark blue effects are the warming effects, and the light blue effects are effectively cooling effects or counter warming effects, the biggest of which are the influence on particles, either directly bouncing sunlight or increasing the reflectivity of clouds. And so one of the first things we talk about with policymakers is the fact that the physical action underlying solar climate intervention is not new. In fact, it's already occurring. It's just occurring inadvertently, and we don't understand it very well. It looks like, because of the level at which it's occurring, it's a really important thing to understand in terms of, our plans to reduce those particulates. So what we have going on today is that we have a highly uncertain cooling effect from the reflectivity generated by particles in the lower atmosphere from pollution. And that effect is projected to go down as we're successful in reducing emissions and reducing pollutants for public health. And so, we have an uncertainty as to what that will mean for heat energy in the Earth system as we bring down that cooling effect that we're generating by accident. We also have an accidental effects going on at the high cloud layer as aircraft traverse through the clouds. And scientists think that the plumes from aircrafts are slightly thickening those clouds at the high layer, and that's causing potentially an insulating warming effect because of the way those clouds work. Air traffic is projected to increase by 7-fold or more over the next few decades, and so that effect could go from being relatively insignificant to significant. And in the stratosphere, where we normally think there isn't a lot of extant pollution, and there isn't today, rockets are traveling through, and a fair amount of the rocket traffic generates the type of pollution particles that could cause this effect in the stratosphere if we're happening at scale. And rocket traffic is projected to increase very substantially over the next few decades. And so it's possible that that traffic could generate the kind of cooling effect that's postulated by solar climate intervention or solar climate engineering. And so what we talk to policymakers about is that we have this open question on this aerosol forcing on climate. And it applies to anthropogenic sources in a way that's really important for what happens to the climate system over the next few decades. And it's a highly overlapping and mostly similar problem as the problem of intentional solar climate intervention, where you're trying to optimize that effect. So what we talk to policymakers about are the kinds of things you might need to do to explore that question. And so that has resulted over the past few years in our legislative work in a program at NOAA called the Earth's Radiation Budget Program. And you can see here the description of what that program is. And it's really looking at the sort of equivalent problem of anthropogenic aerosol forcing and solar climate intervention type aerosol forcing in something that you would look to understand, to be able to detect and monitor, and to be able to evaluate and assess. And so here's the language, the legislative language that informs that. And then how it manifests itself is capabilities for improving the monitoring and baselining of the stratosphere, for example. In this case, there's also a low cloud version. And it links to other NOAA programs where you're trying to increase the observational capabilities of the planet and our ability to evaluate and assess them. In the context of NOAA, and again, I'm focused on the stratosphere, and there are marine cloud and low cloud analogs for this, but the kinds of studies you would do are similar for intentional interventions at the sort of process level, are similar to studies that happen already in how they evaluate the influence of new jet fuels as they're released. And this is an example of that type of experiment where a plume release is made intentionally for the purposes of studying how it flows out into the atmosphere. And so we worked with NOAA on that kind of program, similar with DOE, looking at the influence of particles on clouds and growing our national capabilities to do that, with the idea of working towards, inside the US, a sort of interagency approach to being able to undertake an assessment of these things and to identify the capabilities and science that you would need in order to do that.